Hello everyone, I am Pooja again with you all to discuss about types of heat exchanger. So, as we saw in last video, heat exchangers are classified on the basis of four types. The first one was nature of heat exchange process, second is relative direction of fluid motion, third one is design and constructional characteristics, and fourth one was physical state of fluid. In last video, we have gone through the types of heat exchanger on the basis of nature of heat exchange process. Now, in this video, we will see the classification of heat exchanger on the basis of relative direction of fluid motion. According to that, there are three types of heat exchanger. The first one is parallel flow or unidirectional flow heat exchanger. Second one is counter flow heat exchanger. Third one is cross flow heat exchanger. Let's see about parallel flow heat exchanger. In parallel flow heat exchanger, as per its name, the two fluid stream, hot and cold, travel in the same direction. The two stream enter at one end and leave at other end. In the given figure, the flow arrangement and variation of temperature of fluid stream in case of parallel flow heat exchanger is given. From that, the temperature difference between the hot and cold fluid goes on decreasing from inlet to outlet. This type of heat exchanger requires large area of heat transfer, therefore it's rarely used in practice. As two fluids are separated by wall, this type of heat exchanger may also be called as parallel flow recuperator or surface heat exchanger. The example of parallel flow heat exchanger are oil coolers, oil heaters, water heater, etc. Now, what is counter flow heat exchanger? In counter flow heat exchanger, the two fluid flows in opposite direction. The hot and cold fluid enters at the opposite end. Flow arrangement for counter flow heat exchanger is shown in given figure. The temperature difference between two fluid remains more or less nearly constant in counter flow heat exchanger. This type of heat exchanger due to counter flow gives maximum rate of heat transfer for given surface area. Due to this, counter flow heat exchangers are more favor for heating and cooling of fluid. Cross flow heat exchanger. In this, the two fluids, hot and cold, cross one another in a space usually at right angles. Shown in first figure of cross flow heat exchanger, hot fluid flows in separate tube and there is no mixing of fluid streams. The cold fluid is perfectly mixed as it flows through a heat exchanger. The temperature of mixed fluid will be uniform across any section and will vary only in the direction of flow. For example, the cooling unit of refrigeration system. In the second figure of the cross flow heat exchanger, the fluid follows a prescribed path and is unmixed as it flows through a heat exchanger. Hence, the temperature of fluid leaving the heater section is not uniform. Automobile radiator can be an example of such type of heat exchanger. Now, let's see the types of heat exchanger on the basis of design and constructional features. So there are total 4 types according to this. First one is concentric tube heat exchanger. Second one is shell and tube heat exchanger. Third one is multiple shell and tube passes. And the fourth one is compact heat exchanger. Let's see about concentric tube heat exchanger. In this type, two concentric tubes are used, each carrying one of the fluid. The direction of flow may be parallel or counter. The effectiveness of heat exchanger is increased by swirling flow. In shell and tube heat exchanger, one of the fluid flows through a bundle of tube enclosed by a shell. The other fluid is forced through the shell and it flows over the outside surface of the tubes. Such an arrangement is employed where reliability and heat transfer effectiveness is important. With the use of multiple tubes, heat transfer rate can be improved due to the increase of surface area. Multiple shell and tube passes. Multiple shell and tube passes are used for enhancing the overall heat transfer. Multiple shell pass is possible where the fluid flowing through the shell is reroute. The shell side fluid is forced to flow back and forth across the tubes or by baffles. Multiple tube pass exchanger are those which reroute the fluid through the tubes in opposite direction. Compact heat exchanger. These are a special purpose heat exchanger and have a very large surface area per unit volume of heat exchanger. They are generally employed when convective heat transfer coefficient associated with one of the fluid is much smaller than that associated with other fluid. The example of compact heat exchanger are plate fin, flattened fin tube heat exchangers. We will see the classification of heat exchanger on the basis of physical state of fluids. According to that, there are two types. The first one is condenser and the second one is evaporator. Now let's see about condensers and evaporator. First we will see about condenser. In condensers, the condensing fluid remains at constant temperature throughout the exchanger, while the temperature of the colder fluid gradually increases from inlet to outlet. The hot fluid loses latent part of the heat which is accepted by cold fluid, while in case of evaporator, the boiling fluid, that is cold fluid, remains at constant temperature while the temperature of hot fluid gradually decreases from inlet to outlet. So this is all about the classification of heat exchanger. Thank you for watching.